Hello and welcome to the notes on trapezoids and kites. All right, so let's define a trapezoid. A trapezoid is a quadrilateral, four sides with exactly one pair of parallel sides. What do you know about the measures of angle T and P? And then what do you know about the measures of angle R and A? Well, to analyze this, we have to remember that parallel lines, if this is my parallel line and this is my parallel line, and then TP is the transversal, this angle here, angle P and angle T, those are consecutive interior angles. They're CIAs. So if you remember from chapter 2, I think, CIAs are always going to be supplementary. Consecutive interior angles are always supplements. So then if I use that over here as well, this angle and this angle, and I'm not going to mark them, but if this is my transversal and this is one of my parallel lines and this is the other parallel lines, this angle here, R, and angle A are also CIAs, so those are going to be supplementary. Now, there's nothing that says that they're congruent to each other. So for example, if I said this is 140, I would know that this angle is 40 because they have to add up to 180. But now, if I say this angle R, it has no relationship. It's not a parallelogram, so I can't say, oh, opposite angles are congruent, because a trapezoid, if you look at the quad tree, is in a whole different branch. So it does not have the properties that a parallelogram has. If it did, it would be a parallelogram. So like here, this could be maybe 70 degrees, and then this is 110 degrees. So I can only find those CIAs formed by the parallel lines in their transversal. So next, let's talk about the parts of a trapezoid. A trapezoid has bases, and the bases are my sides that are parallel. So let me write that in here. The bases are the parallel sides. The legs are the non-parallel sides. So this leg and this leg are my non-parallel sides. Okay, we call the bases the parallel sides, and the legs are the ones who are not parallel to each other. So in this case, TP is not parallel to RA. TR is parallel to PA, and again, these little arrowheads, that's what that means, that that side is parallel to that one. If these two sides were meant to be parallel, we'd have double arrows on each of those. They're not there, so we know that they're not parallel. All right, next thing is base angles. So a trapezoid has base angles. Here, this arrow should be pointing to angle P and angle A. Those are base angles, and then there's another set of base angles. So a trapezoid always has two sets of base angles. And a common mistake that kids make is they think base angles are congruent. They are not, as indicated here with this one and double arc. They're showing that they're different. In a special type of trapezoid, they will be the same, but not in just a generic trapezoid. Okay, so here are the properties of trapezoids. The consecutive non-base angles are supplementary. So consecutive non-base angles, so if these are base angles and these are base angles, the non-base angles that are consecutive next to each other are these. And those are supplementary because of the fact that they're CIAs. And then these two are going to be supplements, non-base angles that are next to each other, also because they are CIAs. Other than that, there's nothing else really exciting about a trapezoid. So as per usual, we are going to prove that a quadrilateral is a trapezoid in a coordinate plane. And the way that we would do that is we would show that it has one pair of parallel sides and the other pair of sides are not parallel. So when you do your little rectangle of find the slope here, find the slope here, find the slope here, find the slope here, we'll have one set that's parallel. Maybe these two would be parallel. They'll have the same slope. And then these two are going to be totally random other slopes that are not the same, not equal to each other. So therefore, we would prove this is a parallelogram. All right, so even in the quad tree, underneath the trapezoid, we then have a more specialized trapezoid, and that's an isosceles trapezoid. So what distinguishes an isosceles trapezoid from just a regular trapezoid? It's the fact that the legs, the non-parallel sides, are congruent. So remember these little tick marks, that means that they are congruent to each other. So here we would have that pair of sides congruent, and then you could put arrows here showing that those two sides are parallel. All right, so a trapezoid has a pair of congruent base angles if and only if it is isosceles. So the if and only if, what that means is if you switch the beginning part of the statement, the hypothesis, with the end part, the conclusion, that'll also be true. And if and only if is a biconditional, meaning if you, again, if you flip-flop the front and back ends, they're going to be the same. It's still going to be true. So here it would say a trapezoid is isosceles if and only if it has a pair of congruent base angles. And then the second property is a trapezoid is isosceles if and only if its diagonals are congruent. So in this picture, what would happen, the base angles are congruent, meaning G would be congruent to O, because that's a set of base angles. They're connected to the same base. And then F would be congruent to R. Now the second property here says that the diagonals, so from F to O, and R to G, those two are congruent. FO is congruent to RG. So that is a property that is shared with one of the parallelograms. Where does that occur first in a quad tree? It starts at the rectangle. A rectangle also has congruent diagonals, and then a square does. So if I asked you, tell me all quadrilaterals that have congruent diagonals, there's 3 of them. There's a rectangle, there's the square, and in isosceles trapezoid. Those are the 3 that for sure have congruent diagonals. Now we're going to talk about trapezoid midsegments. The midsegment of a trapezoid is a segment that connects the midpoints of the legs. Now notice it's just a trapezoid. It does not have to be isosceles. This works for both trapezoids and isosceles trapezoids. And the property of that, so midsegment, imagine the legs, you find the midpoint of one leg, the middle of the other leg, connect it. So there's going to be a segment in the middle of your trapezoid. Let me draw it kind of to show you. So here's the midpoint. I would show that by doing tick mark, put a middle there, tick mark, and then I would draw in the midsegment. It is right here. Okay, here are the properties of a midsegment. It is A, parallel to the bases. So here were my bases that were originally parallel. This midsegment is also going to be parallel. And it's going to equal, its length is equal to the average length of the bases. So the average length of the bases is I would take the length of base 1. That's not how you spell midsegment. Whoopsies. Midsegment. Oh gosh, that's bad writing. Okay, it's going to equal base 1 plus base 2, so however long the first base is, plus however long the second base is, and then you would divide it by 2. That's what it means for the average. If there's 2 bases, you're going to divide by 2. If we had to find the average of 16 items, we would divide by 16. So here are those properties illustrated using this picture. We have trapezoid, TRAP. The midsegment is drawn in, so here I would know that TM is congruent to MP, RD is congruent to DA. So you would add the top base, TR, right here, plus the bottom base, PA, however long that is, and divide by 2. Another way to think of that is you could take that half out, right? You could factor it out, put it out in the beginning, and then inside you would have TR plus PA. And then all 3 of these segments, the bases, along with the midsegment, are all parallel to one another. So we get consecutive angles here, consecutive angles here, consecutive angles for the whole thing, and so on. Just a lot of different things that you could apply that we've learned in this class. All right, so now let's do our first example. How long is segment TS? Well, the midpoint, remember, is equal to, or midsegment, is equal to base 1 plus base 2 divided by 2. I have the midsegment here. It's 38.5. Equals, I have one of my bases, 26. I'm missing my other base, TS. Oops, this should be a plus sign. And then I divide by 2. How you solve this is up to you. You could go ahead and multiply both sides because this is a common denominator of 2. I can multiply both sides by 2 if I want. What I could do is put 38.5, put it over 1, and then cross multiply. It's your choice, but either way I do this, I'm going to get 26 plus TS equals 38.5 times 2 is 77. Subtract 26 from both sides. 77 minus 26 is going to equal 51. And you could do a really quick check on your calculator. See, is 26 plus 51 is that sum, when I divide it by 2, does it give me the mid-segment value of 38.5? It should, so therefore I would know that that part of my problem is correct. Right, now the second thing they're asking us here is if angle HAM measures 98 degrees, sorry, this kind of like got squished there, but if this angle right here, HAM, is 98 degrees, what's the measure of RMS? This angle here. Keep in mind, these three segments, this is parallel to this, is parallel to the mid-segment. So this angle here, if this is my transversal, here's one parallel line, here's my other parallel line, what relationship will this angle have to this angle? Hopefully you realize and remember those are corresponding angles, so the measure of angle RMS is going to equal the measure of angle HAM, which is 98 degrees. All right, so that's all about trapezoids. Now let's switch gears to kite. A kite now is its own branch from quadrilateral. So we have parallelograms and all of its, babies underneath. Then we have the trapezoid, which has its own little offspring of a isosceles trapezoid. And then in a branch all on its own is the kite. A kite is a quadrilateral, so again, 4 sides, with 2 pairs of consecutive, meaning next to each other, congruent sides, but opposite sides are not parallel. So that's why this side and this side, they're consecutive next to each other and congruent. This side and this side are consecutive, they're next to each other, and they're congruent. Now the reason that opposite sides can't be congruent, if this side was congruent to this side, that's one of the properties of a parallelogram, is that both pairs of opposite sides are congruent. If we had opposite sides being congruent, this wouldn't be a kite anymore, it would be a parallelogram. All right, so then we're being asked, why is triangle KIT, so this one, why is it congruent to KET, this one? So what happens is, if you remember from our congruent triangle chapter, if you have 2 triangles that share a side, this side is congruent, this side's congruent to this side is congruent to itself by reflexive property, so by side, 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 those 2 triangles are congruent. Which would then, by CPCTC, mean that the angles are all congruent. So like this angle would be congruent to this one. How that transposes or transfers to my picture is angle I is congruent to angle E. Then I would have that, let me just switch my colors here. This angle is congruent to this one by CPCTC. In my picture, that's this one and this one. And then lastly, this angle would be congruent to this angle by CPCTC. In my picture, it's this one and this one. So that is going to lead us to some properties here. So let's go through the properties of a parallelogram. The diagonals are perpendicular. How would I draw that in this picture? I would draw one right angle. I don't have to write all 4. That looks kind of weird. Exactly 1 pair of opposite angles are congruent. These are the angles between the non-congruent sides. So from previously when I showed you the top triangle here is congruent to the bottom one. By CPCTC, those 2 angles are the congruent ones. And one diagonal, only one of them, is the perpendicular bisector of the other diagonal. So the diagonal that connects the congruent angles, so in our case, IE, is bisected by the other diagonal. So what that would show me is that this segment from I to this point is going to equal the same length as E to that point. So I did a triple to show, because we already had single here, and then we have double tick marks here, so I did triple tick marks. So from I to that point of intersection is going to equal the same as the intersection to E. Now angle, so here, yeah, it shows KIT is equal to KET, and KT is the perpendicular bisector of segment IE. So our first problem here is, what is the perimeter of triangle RATS? Perimeter, again, is the distance all the way around. So I need all those 4 segments on the outside. Kite, because the diagonals are perpendicular, leads us to a lot of right triangle information, such as Pythagorean theorems, such as trig that we could use. Law of sines, law of cosines could be used. Everything that we've learned before can be used again. So one piece of information that they gave me here is that RT, from R to T, is 24. So earlier we said that the diagonal that connects the two congruent angles, so remember angle R is congruent to angle T, we actually don't need that here, but that diagonal gets split in half. So if the whole thing is 24, that makes this 12 and it makes this 12. So I need to find RA, because whatever RA is, TA is the same length. And then I also need to find TS, because whatever TS is, RS is that same length. So when I look at RA, in my mind, I see that we have 12 and 12. That's a 45, 45, 90 triangle. So I could do Pythagorean theorem. Sorry for that bell. I could do Pythagorean theorem. I could do 12 squared plus 12 squared equals RA squared. And I will get the same answer because I want to simplify it. I don't want decimals. But if you can recall special right triangles, look at this. It's 12 root 2. Leg, leg, leg root 2. So then this is also 12 root 2. So now we have to find the length of either SR or ST, doesn't matter which one because they are congruent. Let's just do, because I have room down here, let's just do ST. So I would take the leg squared, 20 squared, plus 12 squared is going to equal the segment ST, the hypotenuse squared. Because remember, leg squared plus leg squared equals hypotenuse squared. All right, so let's work through this. We get 400 plus 144 equals ST squared. I get 544 equals ST squared. I'm not going to use my calculator and square root this. 544 is not a perfect square, so I'm going to have to simplify it. So ST is going to equal the square root of 544. I don't know what I've been saying. I think a different number, but you know what I mean. 544. Let's figure out what this would equal. If you don't know the perfect squares that go into 544, remember you could do prime factorization. This is 2 times 272. Circle the 2 because it's prime. This is 2 times 136. Circle the 2 because it's prime. This is 2 times 68. Circle the 2 because it's prime. 68 is 2 times 34. Circle the 2 because it's prime. And then 34 is 2 times 17. Circle the 2 because it's prime. Circle the 17 because it's prime. Now prime factorization, you look for 2 of a kind. So of these two 2's, 1 escapes, and I should have a square root over here. Of these two 2's, 1 escapes. This 2 has no 1, the 17 has no 1. So what this would equal in finally, we would multiply these 2 together. You get 4 square roots of, and then I multiply these 2 back together. I'm not going to circle in the same color, but you multiply those 2 back together and you get 34. However, we are still not done with this problem. We have to find the perimeter. The perimeter is going to equal this side, 12 root 2, plus this side, which is also 12 root 2, plus 4 root 34 plus 4 root 34. When I'm combining radicals from the beginning of the year, we can only combine radicals if they have the same radicand, the number underneath. So I could combine 12 root 2 with 12 root 2, and I would only add their coefficients. It's kind of like terms. I could only add coefficients. It's going to be 24 square roots of 2, and then I do the same thing, but for the radicals of 34. So 4 root 34 plus 4 root 34 is going to equal 8 root 34. What are my units on here? I don't know that I have any. I don't, so I would just say units. It's not units squared or anything, it's just units. The approximate answer, if I use this on my calculator, would be 80.6. But you should all know that most of our assessments, it always says exact simplified answers. So you either want to rewrite your decimals into fractions, if they can be, or leave your radicals in simplified form. That's exact simplified form. Those two options, that's it. All right, last example here. How big are angles U and S? Well, one thing that you have to remember here is that in a kite, these two angles are congruent to each other. So I would add the 3 of them. I could call them X if I want because they're the same. And so now I would do 62 plus X plus 132 plus X is going to equal 360. A kite is still a quadrilateral, so the angles, the inside angles, the interior ones still add up to 360. So let's combine like terms. I would have 2x plus 194 equals 360. Subtract 194 from both sides, you're left with 2x on the left equals 360 minus 194 is 166 degrees. So x is going to equal, divide both sides by 2, we get 83 degrees. All right, so the next time we see each other in class, you're going to work on the trapezoid and kites practice. Try to eliminate these day numbers. It kind of doesn't line up this year. But I do have a joke for you. Why couldn't the pony sing a lullaby? She was a little horse. All right, everyone, thank you so much for watching. Have a great day. Bye.